Alright, in this video I'm going to briefly explain the MSI synchronous counting gates, the 74LS163 and the 74LS193. Beginning with the 163, it's a 4-bit counter with a preloaded count start, which means it will start at 0 unless I tell it otherwise, which is pretty easy to do. It has both a synchronous load and clear, so it can reach a number and reset to a different number. 2 count enable inputs, which we don't really use very much, and a carryout signal for counter cascading. So basically I can tell it where to start and stop with relative ease. The only downside to this gate is that it cannot count downward, whereas SSI, just using the D flip-flops or JK flip-flops, I could count up or down, but with this gate I cannot count downwards. So in activity 3.3.2 I built a circuit using this gate to count from 2 to 9. First I wired the ENP and ENT, which are the count enable inputs, to 5 volts because that's just what I was supposed to do, and we just don't really deal with them. Then I wired the binary count of 2, which is 0010, using ground and VCC into the inputs, which basically sets up what number the circuit will load to when cleared. Then I wired the binary count of 9, which is 1001, from the outputs to the load, so when the circuit reaches 9 it will reset to 2. Here's a video of it working on my physically wired circuit.
Two things that you can win against and 2 things that you can lose against.
And B and C. Yeah. Input.
Rock crushes lizard, lizard eats paper. Scissors cuts.
After having created the 2 to 9 counter, I was then asked to create a 4 to 14 counter, which was done by simply changing which binary counts were preloaded and which ones reset the circuit to the load. And I've just got some pictures and video for that. Next, in activity 3.3.3, I used the 74LS193 MSI synchronous counter, which is probably my favorite gate so far this year because it can basically do everything that we've had to use combinations of gates to do so far. It functions basically in the same ways as the 163 as far as wiring the preload, load, and clear. However, the major difference is that it can count both upwards and downwards. This is done by wiring the desired direction to the clock while wiring the other to VCC. So if I wanted to count up would go to the clock and down would go to VCC. And this is, because the signal is automatically inverted by the gate, the gate operates on the falling edge of the clock pulse. But it works the same way as the 163. I was asked to build a circuit that counts from 13 to 6, which was done by wiring the binary equivalent of 13, which is 1101, as the preloaded count start, and wiring from the outputs the binary equivalent of 5, which is 0101, to the load, in order to make the counter reset to 13. I chose to use 5 because had I used 6 it would have reset as soon as it reached 6, rather than allowing it to count through 6 and then reset. I'm pretty sure this is because the clock operates on the falling edge. In any case, when counting using this gate, just use the digit following the number you want it to reset on. So if I was counting down and I wanted to reset on 4, I would wire the binary equivalent of 3. Or, as is the case of the next circuit I had to build, if I was counting from 6 to 13, which is upwards, I would wire the outputs to the load so that it reset on the binary equivalent of 14. And that's what I did, and it worked. So for this final circuit, all I did was rewire so that the binary equivalent of 6 was the preloaded count. The outputs would set the circuit to load the binary equivalent of 14 when it was reached. And I wired the clock to up rather than down, And that is how the MSI synchronous gates 163 and 193s work. Thanks.